First thing that we're going to cover in this week is rolling maintenance, and rolling maintenance as it pertains to replica sets in particular. That's essentially your requirement here. To be able to do the rolling maintenance as we're about to describe it, you need to have a replica set, and in fact, to do it comfortably without introducing extra risk, I would say that you need to have a 3-node replica set as your minimum. Basically, it involves taking down a node, performing some unit of work, and then restoring that node back into the set. So I mentioned first of all that you're going to want to have a replica set to do this without causing any downtime. You're going to have to make sure that you have sufficient oplog time to cover whatever this unit of work is. But for now, let's get on to some of the mechanics of this. So first of all, a quick refresher. The oplog is a capped collection, right? So you've got a newest entry and an oldest. And the difference in time between the newest and the oldest is what's referred to as your oplog window. And exactly what this is on any given system is dependent on a couple of different factors. So the size of the oplog, the rate at which those new operations are arriving, and of course the size of the operations themselves. You can imagine that if the operations that are being added in here to the oplog are containing very large objects being set or inserted, then that's going to fill up a fixed space more quickly than if you're inserting much smaller objects into the database. But this oplog window value is very important. If you increase the rate at which you're inserting the operations, or you vastly increase the size, or any of these variables change, then your oplog window is going to decrease. So here's our primary that we used in a previous module, still running here. And what I'm going to do is I'm going to use the print replication info command here to show us the first op time, the last op time, the size, and the actual oplog window itself. So this is just a test setup, so as you can see the oplog size is quite small, only 40 megs. The log length from start to finish is 518 seconds, so 0.14 hours. So not very long. As you can see, there actually haven't been any operations inserted here for several hours. What I'm going to do here is reuse one of our previous little code snippets, just a very quick for loop. I'm going to insert 100 documents, 10k each, in here, and just show you the effect that that's going to have on the replication info that we printed out just a short time ago. There you go, returns quite quickly. And now you can see, having inserted those operations, filled up our oplog quite quickly, and we are down to now 0.02 hours, 75 seconds just. So let's do that again and see what happens. Interesting enough, it's actually 0.03 now, so probably because of the gap that I did there in between inserting those operations, it did it. But you can see the effect that having a high insert rate or inserting large documents is going to have on your oplog size. So this is somewhat a contrived example. You're very rarely going to have an oplog size as small as the one I have here, but I think it illustrates the point nicely. So the methodology when you're actually going to implement this is pretty straightforward. So let's say we have a replica set. And briefly before we go into this, let's just talk about what happens if this is an arbiter. If this is an arbiter, then the only secondary remaining to you to actually do this maintenance will be this one here. You're left with just the primary in terms of copies of your data. And so that's a little bit dangerous. You've got nothing that can take over should that primary fail, because you've taken this one out and you're doing some sort of maintenance on it. In this scenario, it will still work. Your replica set will stay up. You will still be able to add this secondary back in. It will still be able to catch up and all the things that it needs to do. But I think that when you do it in this configuration, you're just adding too much of an element of risk here. It's still the best way to go about maintenance on a particular node. The best practice recommendation would be to have at least 2 full secondaries. So the methodology here is we take this secondary, we shut it down. Now perhaps the unit of work that we're actually going to do on it is very simple. We're going to upgrade the MongoDB binary on it or something similar to that, in which case you just replace the binaries and start it back up again. Perhaps the maintenance that we're going to do requires the MongoD here to actually be running. Now your replica set is still over here functioning away, accepting writes, etc. And that's still functioning. Now if we bring this one back up, it'll attempt to rejoin. These ones will still be constantly pinging this host on the configured port to see, is it there, is it back, is it healthy, has it just dropped off the network for a little bit. So if we require this to be running, what we actually need to do is start the MongoD process on this node without the --repl set argument, or without the repl set equals name argument in your config file, whichever way you're actually specifying this in the replica set when you're starting it up. And the second thing that we need to do is start it up on a different port. If we leave the port the same and we just remove this replica set argument, this node will no longer think it's a member of a replica set, but these two will still attempt to ping it, will think that it's now healthy, and that's going to lead to a confused state. So the recommendation is shut it down, start it without the replica set argument, and on a different port. Once you've done that, you've got a working MongoD instance that you can connect to with the Mongo shell, and you can perform your maintenance. When you've completed the work that you need to do on this secondary, you shut it down once again, restart it with the original REPL set argument, and restart it on the original port. So you basically go back to your previous settings, your production settings. One of the more common ways to do this is, once it's shut down, is that you actually manually start the MongoD. So a couple of caveats on this. If you're going to manually invoke or start the MongoD process, in other words, run it from the command line yourself, whatever MongoDB normally runs as, make sure that when you invoke or start the MongoD process manually, that you run as the same user, to avoid any issues with file permissions or access rights. If you don't decide to do this, then what you're going to be doing instead is you're going to be either editing your production config file, pointing at a new production config file, or one of these methods. But basically, you want to follow the methodology of shutting it down, changing the port and REPL set argument, and then once you've done your maintenance, go back, start it up as you normally would in production, and revert to the original arguments. Now let's say that we've gone through that process, we shut it down, we restarted on a different port without replica set arguments, and then we did the piece of work that we wished to do, and that took, let's say, 1 hour. We now have restarted this secondary process on its original port and replica set, and we know that we have 24 hours oplog window. So we're well within our oplog window that it gives us to do the maintenance. So we're pretty confident that when we add this back in, it's going to rejoin the set successfully. Before you move on and do the rest of the rolling maintenance pieces, you want to wait for the secondary to catch up. Now this will all depend on, 1, how fast this machine is, 2, how much activity's actually gone on in this 1 hour. But generally they're going to catch up pretty quickly. The way to check is to run the rs.status command, which I've done here on our test set. And what you're going to be looking for is when the uptime values are the same in each case. Now, uptime can be a bit hard to parse. It's this long number here, which is in the timestamp format. To help people out here and make it a little bit more readable, what we've also got is an isodate format. So it makes it a little bit easier to parse, and you can actually see where everything is currently up to. The primary, which we've just run this on, is up to 19th of December at 9 minutes past midnight Zulu time, so I think that's GMT. And we're going to have a quick look at the same value for the secondary. As you can see, it's the same, so these two are pretty much in sync, as is the final secondary, which is what we would expect. Once you see an uptime date that is as you would expect, the only time you would see an uptime date here that's going to be consistent, in other words, if you had a slave delayed secondary, but generally what you're going to want to do is wait for all these uptime dates to agree, and then you can move on with your maintenance. So once you've confirmed that this secondary is caught up, you've got a full and healthy replica set once again, you can move on to the next node essentially. When this is rejoined and you've got a viable working replica set again, the next node you'll do is this secondary. So repeat the process. Take it out, shut it down, restart it on a different port without replica set, redo the piece of work on this particular secondary, whether it be an upgrade or an index build, whatever it is. Restart the process on its original port and let it catch up. And once it's caught up, it will have rejoined, you'll have your whole replica set again. So just repeat the process for the second secondary. The only one left is your primary. Now, as I said before, you don't just want to shut this down like you did the secondaries. What you actually want to do here is do it in a more controlled manner. You want to issue an rs.stepdown command. I'll run that right now on our test set and show you how that works. I'm currently connected to the primary, as you can see. What I'm going to do is issue an rs.stepdown. And as you can see, when you do a step down, it causes an election. It will close out all its current connections, so that's why it disconnects me, but the shell has an automatic reconnect built in, and when it reconnects back, you'll note that we're now connected to the secondary. That's interesting. Which one of our other nodes has become primary, just really quickly. And you can see that the instance running on port 31001 is the one that is now primary. Just to confirm that, yes, we can see that there you go. This is the one that is now primary. You issue the rs.stepdown on the primary. This will step down, become a secondary, and one of these two remaining nodes will be elected to primary. Go. Let's just say it's this one. There is a minor impact application to do this. All your existing connections will be reset, so your driver, your applications will have to open up connections to new primary. They have to discover that there's a new primary, but all of this will take place over a matter of seconds. We're not talking about minutes here. So this is quite a controlled passing of the baton, if you like, over to this new primary, and this will be the new thing taking writes. Everything else will be syncing off of that. Now that you've got your remaining node, which has not had the work done to it as a secondary, repeat the process again. Shut it down, restart it on a different port without replica set, do the piece of work, restart it on its original ports. You will have completely upgraded every node, or built an index on every node in your set, whatever the piece of work is, without or with at least very minimal service interruptions. The only actual interruption here will be the step down on the primary.